it. So, but it is directly related to Industry 4.0, cyber physical framework for fire emergency response in the building. What we'll be doing, we'll be incorporating certain sensors. We'll be creating a model where automatically we'll be having, if we will be having any indication of the fire in the building, we'll having the input, and like we can begin with the any corrective action that is being needed. We'll be doing it with the Western University Canada and IIT Roorkee. One of the professor from the IIT Roorkee is also involved in this. So like if it is approved, we'll be doing it. So these are the projects on which my research group right now working. So now what I'll be doing, I'll be like giving you brief of the idea of how it is being done, one or two projects, as much as I could cover during the allotted time, I'll be covering up. And I'll be first talking about the research about the glasses, and then I'll be talking about the multiple researches that we have done, as much as time will allow. So the first project that I'm going to cover, the results of the project I'm going to cover, it's about developing the fire retardant laminated glasses and improving the load bearing ability of the glasses in extreme condition. Once you talk about the extreme condition, maybe like in aircraft, there is continuous fatigue and creep and different complex loading that is being applied. So we are working on that. So for this project, of course, 4 countries are involved. We have the experimental program here in Spain and in Canada, and numerical modeling, of course, one of the group I was doing once I was in India. I was like involved in the numerical modeling because we are already in completion of this particular project. So kind of, and this is the professor from the Italy who is working with me on numerical modeling. So there are multiple cases in India, even more. We have example of fire, and once we talk about the National Crime Bureau data, it reflects that fire is still the fourth most undesirable disaster that causes the death in India and globally. So there are certain examples of the fire which we have, and to prevent fire, we have this general national building code in India and everywhere else as well. And they do state some guidelines what to do, what not to do to avoid such incidents, and what must be the fire resistance of the building or material. But as I belong to the India, I'm aware that these practices are rarely followed. Very few people test the fire retardancy before making a building. They do even the illegal construction, and that is the cause of fire. So, however, we are also trying to strengthen this National Building Code of India. This is about fire, how it occurs. When it is, we talk about the compartment fire. You must be like there are two kind of fire. One is the like fire in the jungles that we have in Australia or so. We are not working on that kind of fire thing. We are working on compartmental fire. That is within a structure, inside a building, inside a room or so. So what happens initially, fire grows, and once this flashover is being achieved, uh, it is a growth period. And during the growth period, what happens, if we can control the fire, we can control it. But once there is a flashover, we cannot control it by any means until it is fully developed and there is a decay. We can adopt several measures to retard this kind of growth of fire, but it is not controllable in general. So either we try to control it, we try to delay the flashover and control it within that. So my group was working on delaying the flashover by creating the strengthened fire retardant material, be it glasses, be it other structural material. We are working on it so that the we can cut out the oxygen supply and those material do not break, and we could delay the flashover point so that the people can vacate the place, or fire measures to prevent the fire could be taken. So we are trying to do this. This is again Grenfell tire, very famous. It has started because of failure of glasses. Because there was breakage of the glasses, there was a small fire, and there was breakage of the glasses. There was oxygen supply abundantly, and because the building has facets which are very much, all those facets are broken, and it was completely burned within minutes. So this is what the flashover occurs very quickly, and within minutes, the whole Grenfell Tower was burnt, and there was severe deaths and injuries. So this is the basic testing that we have performed about the what kind of strength glasses do have once they are into the fire, and a very interesting result that we have obtained from this once, because glass, you might be aware that glass transition temperature is very high. So we have tested it and we have communicated these results to a journal, and they are published. Like, glasses never fracture because of high temperature. Like, never fracture in the sense, once even there is 500 600 degrees centigrade, glasses can withstand if they are uniformly heated. Uniformly heated means if there is a window and we are having a fire, because of the fire, if there is a complete window is been having the same temperature, it may not broken. But due to thermal gradient, any of the glass structure, any of the building material, or this specifically the glass or laminated glass, they do break because there is a gradient across the length of the glass. If there is a gradient of even 150 to 200 degrees centigrade, the glasses will start breaking. They will be breaking. Even if they have a uniform temperature of 500 degrees centigrade, they'll not break. So this is what the results that we have identified, and we have worked accordingly for like uniformity of the temperature on the glass. We have incorporated certain treatments for that, and we were successful with our intent to an extent. So this is of course what we have done, like mechanical testing post fire, before fire, and of course the in general the mechanical testing. This is a 3-point setup: bending or load bearing ability. We have evaluated. And this is about we need to think of how glass are being made. So it is a very basic floating process which is being used for making the glass. You all might be aware of it. Like we soda, lime, silica glass for we melt the raw materials, and it is being floated, and though that floated thing is being once solidify, and before even recrystallization of the grains, it gets solidify, and we have this transparent glass by this process. I suppose. Okay. So again, one more experiment and numerical model that we have produced. Like, you can see that there are two cases. First case, once there is no expansion is being allowed in the first case on the left hand side, and other side no expansion is being allowed by the glasses because of the frame. If we are having a frame, that will prevent the, during fire, what will happen? During fire, there will be the increase of temperature of the glass, and it will try to expand. Once it will try to expand, it will be having these stresses, and those stresses will cause the gradient, stress gradient throughout, and glass will break. So we have tested that without the restriction, how much temperature a glass can bear, and with the temperature, how much temperature a glass can, with the restrictions or frames, how much temperature a glass can bear. And we have find out these results. You can see the in first case, once there was a restriction or a frame to the window, the glass blast was broken after 60 seconds. And but once there was a restriction around, and we kept the temperature like rising from 0 to around 270 or 280, the glass was broken after 100 seconds. So you can see there is a significant increase in the time once there is no structure and no frame around the glass. So actually these experiments are conducted to understand the behavior of glass once they are subjected to fire, because ultimately what we need to do, we need to make a glass which is fire retardant. So we must understand what is happening within the glass so that we could start thinking about what should be done on the surface of the glass or within the glass, so that this phenomena can be avoided, this phenomena can be delayed, and we could have a fire retardant glass. So these experiments were conducted in order to have this information. So we got very two vital points. One was glass do not break due to the temperature, it breaks due to the thermal gradient across the length of the glass. Second, the if we restrict the thermal expansion of the glass, it starts breaking. Otherwise, we have time and it will not be breaking soon. So these were the 2 points that we have obtained from our experimentation to the glasses, and we worked on it. For modeling, glass is a complex material because it has surface flaws, minor cracks which cannot be observed, and those residual stresses, environmental conditions, surface flaws, non-uniformity of the glasses cannot be modeled. It is very difficult to model this behavior, and we have tried to model it with the Biot number. And Biot number, of course, you might be aware that it gives the information about the flow of heat within the solid. If we want to predict the heat flow in a solid, we can do it by application of the Biot number. Okay, so we have tried to do this modeling. I'm not going to do into the detail of this calculation that we have done. And we have obtained, we had somehow replicate once there is a fire, we have measured the heat transfer within the glass using simple thermocouples, and we have measured that through our model as well. And model was working well up to the 90%. Okay, so these are some outputs of the model. I'm not going into the detail because it is a complex calculation. It might be not useful as much. Now we were like into the creating the glasses for the extreme conditions. So we have tested the all available. The first step is to evaluate the available options. So what we have done, we have evaluated the load bearing capability of all commercially available glasses in order to improve them. So the first step was to, of course, the first step of any investigation should be to evaluate what we are having exactly in the market. So during this, we have calculated or evaluated the load bearing capability of all available options in the market, and we have analyzed them, which is better, which is not better. So later on we could do something with the best available option in the market so that our developed product can be the marketable. So these are some force extension diagram. It is very interesting that for glasses we want to present not the stress strain diagram but the force extension diagram, because it become the dimension independent, and once there is a stress strain it becomes the dimension dependent. So we try to make the force extension more for the glasses. These are the simulation output, like we got the this has been done on simple ANSYS. We have used ANSYS for this, and we have the stress variation during 3-point bending through ANSYS, and we have compared it with the results. These are, of course, a very essential part of any of the experiment, that is the statistical analysis that we have conducted, and we have found that the data was following this pencil thickness test shown in the residual plot. So data was normally distributed. Our results were having the limited error. So these are some output results which we have already, like there is no